Good afternoon. First of all, I would like to thank the hosts of the CubePilot conference for giving me the opportunity to present to you today. My name is Piotr Lazarek, and I'm 18 years old, third grade student of secondary school in Poland, and 12th grade student in Dulwich College in England.
大家下午好，首先非常感谢主办方的盛情邀请，我很高兴能今天跟大家一起探讨和分享。我叫彼得，来自波兰，现在是一名高三学生，同时我也是在德国德威士学院求学。
For more than 5 years, I've been interested in physics, informatics, and modern technology. When 2 years ago I was thinking about the focus of my project to be presented at the Polish National Science Competition, I was considering the idea of building a Mars rover. But after further thought, I realized that there are dozens of competitions around the world in which hundreds of such vehicles have already been presented. So I asked myself a question: would creating another Mars rover change anything? Could my solution be more competitive, more innovative, or even better in any way? Not likely.
5年多以来，我一直对物理学、信息科学和现代科技有着浓厚的兴趣。2年前，当我参加波兰国家科学竞赛时，当时我的想法是建造一个火星探测器，那也是我当时整个项目的核心内容。但后来我转念一想，在全球范围内类似的科学竞赛有好几十个了，而且像火星探测器这样的模型也已经被展示了上百次。所以我开始问自己，是不是我的方案能够更加创新一点，能不能做一些不同的东西，或者是更有亮点呢？
I understood that people love looking at the stars. They work hard to do research which could expand our horizons and help humanity to aim higher. But what about our own backyard? Why don't we use the technological potential which is present within space exploration and adapt Mars rovers into machines which have practical application here on our planet? I simply feel that we ought to find a new usage for them. With this optimistic attitude and a brilliant idea, I stuck with no progress at all. It appeared that inventing something new wasn't as easy as I initially thought.
我明白大家都喜欢仰望星空，努力从事研究，不断拓展自己的视野，帮助人类实现更崇高远大的目标。但是我们有没有想过，其实可以脚踏实地，从身边小事做起？为什么我们不利用探索天外空的先进技术，将火星探测器这样的装置改造成我们生产生活中实际需要的、具有应用价值的机器呢？简单点来说，我觉得我们应该充分地利用这些先进科技的潜能，利用它们来为人类造福。我的态度一直都是非常积极乐观的，同时我的点子也非常好。但是真正当我把这些想法转换成实际的时候，我发现还是有一点困难的。
So, as it sometimes happens, a coincidence helped me. During a chemistry class, I heard a story about some farmland which had suffered due to a high concentration of aluminium ions inside the soil. So I wondered if there was any automatic way to detect the problem before it causes damage to crops. So, acting on my curiosity, I performed some research, and to my frank surprise, it transpired that such a technology hadn't been developed yet.
说来也是比较幸运，正是由于生活中偶然会发生的小事帮助了我。在我的一堂化学课上，我偶然听说一些农田由于土壤中铝离子浓度过高而导致了一些农业损失，所以当时我在想，是否有一种自动检测的方法，能够在农作物遭受损害之前就能检测到它的成因。所以出于好奇心，我做了一些相关领域的调查。然而我惊讶地发现，能检测这种技术的相关装置还没有被开发出来。
So currently, a farmer has to collect samples of the soil manually and send them to the laboratories. And I must admit that such a solution is extremely accurate. Unfortunately, though, there is a cost to this, as the waiting time for the results in such institutions is about 2 months, and it involves high financial costs also.
目前，这样的农田检测装置需要农民手工采集土壤样本，然后送到专业的实验室进行检测。不可否认，用这样的方法检测的结果非常的准确，但是其成本却十分高昂。一般来说，需要等上2个月以上的时间才能够拿到相关的测试结果，而且费用也不菲。
Personally, I think that at the stage of preventive measurement, such accuracy is not necessary. A farmer only needs general information about, for example, the soil acidity. He doesn't pay much attention to the values given in moles per cubic decimeter. He only cares about quick feedback whether the results are within acceptable tolerances. So this is why I came to a conclusion that available solutions aren't suitable for the purpose of preventive measurement of soil condition.
但在我个人认为，在预防测量阶段，并不需要做如此高精度的检测。对于农民来说，他们只需知道土壤酸度的一般信息，而且也不太会注意像每立方分米土壤中的摩尔浓度这么高精度的测量。他们唯一关心的是能否第一时间拿到信息，拿到快速反馈，能否让他们知道这个检测结果是可接受范围之内的。所以我觉得现在的解决方法都不太适合只需采取预防性检测的土壤。
So, sensing opportunity, I decided to design and create such a device on my own, initiating a project and then a prototype of the device, of the vehicle, which takes preventive measurement of soil condition autonomously. The work on developing the project lasted more than 1 year, and the end result is my prototype consisting of several co-working systems, such as pneumatic and hydrostatic system of sample collection, chemical analysis system, and finally a cleaning mechanism for the soil containers.
我觉得我的研究可以填补这个领域的空白，所以我决定自己来创造或者设计这样的一个装置。通过项目启动呢，最终我设计了一个自动对土壤状况进行预防性检测的机器原型。这个项目的开发工作持续了1年多，最终得出了如上图所示的我的这样一个原型，还包括几个协同工作的系统，例如气动和静液压系统、样本收集系统、化学分析系统和土壤容器的清洗装置。
My vehicle uses more than 25 components, such as compressors, pneumatic cylinders, electric valves, engines, and more than 8 sensors. My vehicle uses replaceable ion selective electrode system in order to measure concentrations of different ions inside the soil, and it also uses a humidity sensor in order to generate an irrigation map of the farmland in question.
该装置呢由超过25个部件组成，有压缩机、气缸、电气阀、发动机和8个传感器，使用了一个可更换的离子选择性电极系统来测量土壤中特定的离子浓度，还使用了一个湿度传感器来生成相关农田的灌溉图。
Furthermore, thanks to its GPS, magnetometer, and a series of simple trigonometric functions, my device is fully automated just after receiving coordinates of all measured points. I also created an intuitive mobile application which affords users the opportunity to define the path of the vehicle themselves.
此外呢，这个装置还配备了 GPS 系统和一个磁力仪，在程序当中我又加入了一系列三角函数的运算，所以这样一来，我的装置在接受到所有测量点的坐标之后，就会实现完全自动化的测量。
But before the development of my own autopilot, I had done a lot of research, and this is how I came across the Cube for the first time. So I read a lot about it, and it transpired that it fits my needs perfectly, not to mention Mission Planner, which had already literally every functionality I could think of.
在我开发自己的无人机之前呢，我做了很多研究，在这其中我就第一次遇到了 The Cube 飞控。在那之后呢，我阅读了相关很多的资料，我发现这项技术完全可以符合我的要求，它其中包含的相关的标准参数也已经具备了我能想到的我所需要的每一个功能。
Now I should probably tell you that ever since I can remember, I was passionate about unmanned systems such as drones and rovers. And this is probably why I wanted so badly to create something similar to the Cube on my own. I thought that it couldn't be that complicated, so yeah, I was wrong.
不瞒大家说，从我记事开始，我就对无人机和探测器等无人操作系统非常有兴趣。这也就是为什么我想自己创造类似于 The Cube 飞控的装置。我刚开始以为可能没有那么复杂，但是我想的有点太简单了。
So I bought the cheapest available magnetometer and I connected it to the Arduino. And to my surprise, it turned out that it wouldn't be enough to measure precisely the direction in which the vehicle was heading. So after that, I learned that in order to obtain clear results, I had to add an accelerometer and gyroscope to my autopilot and process the data using Kalman filter. But that was only the beginning because I would have had also deal with a number of serious problems such as temperature and vibration errors.
所以我买了一个最便宜的磁力仪，然后把它连接到了 Arduino 上。出人意料的是，磁力仪不能精确地去测量无人机的前进方向。所以后来我了解到，为了获得更加清晰、更加准确的结果，我必须在我的无人机上加上一个加速器和回转仪。 并使用卡尔默滤波器来处理数据。但是这仅仅是开始，摆在我面前的还有很多棘手的问题，比如由于温度的变化和振动会引起的测量误差。
So eventually, after months of hard work with my mobile application and the hardware of my autopilot, I realized that it would take years before I could make something even comparable to the cube. So I changed my approach. I assumed that the distances between test points on the farmland are so large that such accuracy wouldn't be necessary.
后来的几个月，我都有努力在改进和完善我的无人机的硬件和相关的应用程序。最终我意识到，如果想要做出能跟 The Cube 飞控相媲美的装置，我可能还需要花费好几年的时间。但是在那一刻之后，我改变了自己的方法。我其实有做一些假想，例如农田上测试点之间的距离可能距离会比较宽，所以其实并不需要非常高的精确度。
So right now my prototype compares data given by the magnetometer with the displacement vector provided by the GPS. And after all, it seems to work very well. Now I know that I would have saved a lot of time and for sure a lot of money if I bought the cube at the beginning. Nevertheless, I learned a lot during the process.
现在我的无人机原型能比较磁力仪提供的数据和 GPS 提供的位移矢量，目前来看运行的还不错。但是现在我其实有一点后悔，如果我从一开始就能够买 The Cube 飞控产品的话，其实会很节时省力，同时也会更省钱。但是其实在自己慢慢摸索的过程中，我也学到了很多东西。
So now I would like to show you a short movie which shows step by step the principle of operation for my device. So as you can see, the user interface is based on merely 3 buttons and commonly known Google Maps system. In order to set the positions of the test points, user clicks Add New Test Point button and then highlights desired points on the map by touching them. So after that, the user has to send the coordinates to the device by clicking Upload Path button, and that's all. From there on, the vehicle becomes fully autonomous, and he has nothing left to do but wait for the results.
接下来呢，我想展示的这个短片是让大家进一步来了解我的整个设备的操作原理。大家可以看到，其实在用户界面上只是有3个按钮和常用的谷歌地图系统。用户只需点击添加新测试点这个按钮，就能在地图上选择所需要突出的区域，就能够精确的去选定测试点的位置。接下来你只需要单击上传这个按钮，就可以将所有测试点的坐标发送到设备。所以当这个坐标发送成功之后，整个无人机的运作就变得非常的自动化了。所以无人机就开始了它的自动的校准程序，比如说重新加压气动系统然后整个视频中你可以看到无人机是从最近的测试点加速前进，所以在整个航行过程中呢，它可以每秒钟分析自行的位置，并且利用一系列的简单的三角函数去进行航向的校正。所以当无人机到达指定地点之后呢，它会开始进行土壤取样，依次将样品装入容器当中，准备土壤溶液，然后测离子浓度。所以无人机只需在测量点花费几秒钟的时间去收集样本，然后剩下的程序就可以在它前往下一个测试点的过程中完成。
Okay, so perfectly. So now the vehicle accelerates towards the nearest test point. During its passage, it analyzes its position each second and makes course corrections thanks to the simple trigonometric functions. Yes, so when it reaches its indicated position, indicated place, it begins the sequence of soil sampling, transporting soil to the container, preparing soil solution, and finally measuring the ions concentration.
现在大家看到的视频就是我们刚才有介绍过的，就是在农田中进行土壤取样，并且进行配置土壤容器测量等一系列的过程。
The vehicle spends only a few seconds in the measuring points, as it is enough time to collect the sample, and the rest of the procedure can be done on the way to the next nearest test point. This situation seems to be very beneficial even from the economic point of view, as the cost generated via measurement point resolution in my solution increase linearly, while in alternative solution they increase squarely.
所以大家可以看到，其实整个无人机在采取 采集土壤样本的时候花费的时间非常的少，所以从节约成本的方面来看，这种检测方案有很多的优点。因为在我的解决方案当中，测量点分辨率所产生的成本其实它是呈线性增加的，但是在其他方案当中，这种成本会更高。
So as you can see, when immediately after the vehicle reaches the start point, the results are being sent to the mobile device and published under the results tab. Results are presented in the form of colored markers, and in order to get precise measurement results, the user touches chosen marker, which results in it displaying the value of specific parameter. Yes, so until now, the taking of preventive measurement of soil condition has been considered time-consuming and expensive task, which has led to most farmers opting against collecting data. My prototype significantly decreases such time and financial restrictions, and thanks to its simplicity of use and autonomous nature of its operation, it could be used by anyone. So I believe that my innovation could become a widely used tool which could pave the way for the preventive measurement of soil condition becoming much more commonplace.
说到无人机它采集了土壤样本之后，那用户是怎么去得到它这个结果的呢？这就要回到我们说无人机回到起始点之后，它会分析它的样本测试结果，会立即发送到移动设备上。那用户可以在结果选项中去查看它的检测结果。检测结果是以彩色标记图表的方式呈现的，所以如果你想获得更加精确的测量结果，你只需要点击所标记的区域，就可以显示特定的参数值。所以即使是今天根据土壤状况采取预防性测试呢，确实是非常的耗时，成本也非常的高，而且这又导致了很多农民他会不收集数据，不做检测。那我的机器原型呢，它能大大的去缩短检测时间，减少检测成本，而且操作简单，高度自动化，能为用户提供更多的便利。我相信我的创新设计可以成为一个为人们所广泛使用的工具，也能够进一步推动并促进土壤预防性检测的普及。
So I have learned a lot about unmanned technologies during development of my recent project, and thanks to that, right now I'm in the middle of developing my new idea, which is strictly connected to the HEX technology products. I hope that in the future we'll have an opportunity to cooperate in this regard, and if everything goes well, I would love to present it to you in the future. Thank you very much.
在我最近的项目开发过程中呢，我学到了很多有关无人机科技的知识，也正是由于这一点，我才能想出现在的新点子。我这一想法其实跟鹤信无人机科技的产品密切相关，所以我希望我们有机会能在这方面进一步合作。如果一切顺利的话，我非常乐意在将来的某天跟大家一起分享我的成果。谢谢大家。